Hello, my name is Vinícius. I'm from UFMG, Brazil, and today I'll be talking about a new variant we propose called the clustered orienteering problem with function-based rewards. So, most routing problems consider the customers as fully independent or clustered, meaning they are brought together in some way. For example, the clustered orienteering problem groups customers and takes on an all or nothing approach. But what about partial reward scaling? Meaning we have different clusters and each of them scale their reward differently. For example, in 3D aerial scanning, scanning a tree is way different than scanning a rectangular building, even if they are of the same size. To describe our problem more formally, we are given a set of target positions, which are clustered, and a reward function for each cluster. The reward function scales with the number of visited targets within the cluster, and we are given finally a time budget. Our final goal is to determine a trajectory that maximizes the total collective reward respecting the total time budget. So this is an optimization problem. So here's a more direct comparison to the COP. We have our quadratic cluster with C targets, and in the COP, which takes an all or nothing approach, it doesn't use its functions. So we only get the reward when visiting all of the customers in the cluster. In our approach, which uses partial reward, we get the reward even if we don't visit all of the customers. Indeed, in the quadratic function, we get the maximum reward when visiting only half of the customers. For solving our problem, we use a genetic algorithm. Firstly, we model the functions as black boxes, and secondly, we modeled our problem as a multi-objective problem, since we know efficient paths form good solutions. So the first objective was the total solution reward, and the second was the solution efficiency, which is the total reward by the total distance. This leads to a more competitive environment in the genetic algorithm, but since this is still a single objective problem, our best solution is still the solution with the highest total reward. For our experiments, we use the set orienteering problem dataset, and we use these four types of functions for our clusters, setting the global maximum to the cluster value in the original dataset. We also compared our proposed solution with different methodologies, such as the single objective model, which only the reward is actually evaluated, and a sequential visit of clusters, meaning we have to visit everything we want in a cluster before visiting the points of another cluster. So here's some results. In the left, we have an instance in which clusters were assigned a random function. And in the right, we have the comparison between our proposed method and other methodologies, as we explained. And we concluded that our chosen methodology was better in small, medium, and large instances. In conclusion, we propose an initial solution to this new clustered orienteering problem variant with consistent results at reasonable runtimes. However, the black box approach, coupled with the genetic algorithm greediness, tended to disregard certain functions, such as the exponential function.